This is the surface area and volume of spheres tutorial. Let's begin by taking a look at a couple common examples of spheres in the world. On the left-hand side, we have a picture of the Earth in a child's hands. The Earth and every other planet and star that we know of exists as a sphere. In the middle we have a soccer ball, and on the right your common dandelion wishing flower. Those are all examples of a sphere in the real world. Now let's take a look at some important formulas about spheres. The two important formulas that we're going to discuss in this tutorial are how to calculate the surface area of a sphere and how to calculate the volume of a sphere. In order to calculate surface area, we multiply 4 times pi r squared. And volume is calculated by multiplying 4/3 times pi r cubed. So I'm going to bring in an example sphere for us to work with. Now you can tell in this sphere that it has a diameter of 24 inches. And we want to deal with radius for both of these formulas. So radius is always half the diameter of a circle. And you can see the cross-sectional area right here that we're dealing with in this sphere creates a circle. So the radius of that circle is going to be half of its diameter. So from here to here. And that's going to be 12 inches. And we'll use that to solve for surface area and volume. Let's begin with surface area on the left. Surface area is equal to 4 times pi times our radius, which in this case is 12 inches, squared. So we'll simplify that now. We have 4 pi times 12 squared, which is 144. Now we want to multiply 144 times 4. When we do that, we'll get that our surface area is 576 pi inches squared. Now I'm going to leave my answer in the form of pi here. Since pi is an irrational number, the most exact way that you can leave your answer is to leave it with pi involved. We could multiply out pi 3.14 times 576, and some teachers prefer your answer like that. However, the most exact form is what we have here. Now let's take a look at the volume of a sphere. Volume is calculated by multiplying 4/3 times pi times our radius cubed. And our radius again is 12 inches. So the first thing we're going to do is cube that 12. 12 cubed is 1728. So our volume is 4/3 pi times 1728. Now you can multiply by 4/3 or you can multiply by 4 and then divide by 3. Either way you'll get the same answer. When you do that, we get 2,304 pi. And it's going to be in cubic inches because remember, whenever we're discussing volume, we're discussing 3 dimensions, which means that our unit is going to be raised to the 3rd power. Now let's take a look at a more difficult application of this sphere formula. Here we have a composite figure. You can see that we have a cube with a sphere inside of it, a half a sphere here. Now, if I were to tell you that this cube had a side length of 4 inches, I'd like you to calculate the volume of this composite figure. Now remember, we're dealing with a cube that's missing the volume displaced by half of a sphere. So what I'm going to do is shade this figure in. The dark purple is the volume that we're looking for. That light purple represents the inside of that sphere that's been hollowed out, almost like half of an orange, sitting on top of that. So let's start with what we know. We know that the side length of this cube is 4 inches. Now the formula to calculate the volume of a cube is side cubed. And since we know that for our cube, it has a side length of 4 inches, it's just going to be 4 inches cubed. And 4 cubed is 64. So we have a total volume for this cube of 64 cubic inches. Now that would be if it wasn't missing half of this sphere. Half of that volume has been displaced there of that spherical volume. So what we want to do is solve for the volume of a sphere and cut that volume in half and then subtract that amount from the volume of our cube since it's missing from there. So since we know that the side length of this cube is 4 inches, that side length can be drawn right across this sphere right here. That would be the diameter of a circle that's cut right at the middle of the sphere. And we want the radius. So the radius is going to be half that diameter. This distance right here. And half of 4 is 2, so the radius of this sphere is 2 inches. So I'll go ahead and use our volume of a sphere formula, which is 4/3 pi times radius cubed. So the volume of our sphere is 4/3 pi times our radius, which is 2, cubed. And you know 2 cubed is 8, so we have the volume of our sphere is equal to 4/3 pi times 8. 4/3 of 8 is 10.7, so the volume of our sphere is 10.7 pi cubic inches. Now we don't have a full sphere, we have half a sphere, so it's only displacing half of that volume. So when we divide 10.7 pi by 2, so our volume of our sphere is 10.7 pi divided by 2, which is 5.35 pi inches cubed, which is roughly 16.81 inches cubed. So that's the volume of our semisphere here. Now we want to take that and we want to subtract it from the volume of the cube, because that semisphere is cut out of the cube. So I'm going to take our volume of our cube, 64 cubic inches, and I'm going to subtract 16.81 cubic inches from that. When I do that, we'll have 47.19 inches cubed. So that's going to be the final answer for the volume of our cube. We took the volume of the cube and we subtracted the volume of the semisphere. Now remember, in the future when dealing with spheres or semispheres attached to another figure, so composite figures like that you're going to be either adding or subtracting the volume of the sphere depending on whether or not that sphere is cut out of the figure or attached onto the figure.